Hello everyone, once again welcome back to the quantum world. So in our last session we have seen the different algorithms, okay, the way of writing an algorithms and like GPU and the quantum computing. So in our computer science field already we know our ultimate goal is to optimize the time complexity, and that's why the different kind of device and algorithm was designed. Yes or no? So finally, the one basic questions arise in our mind. Supercomputer. Is it really exist? So my dear friends, whenever you are saying the term super, it means it is a dead end. Nothing can be go beyond that. So obviously we cannot define the term supercomputer. Obviously many people use this term in day by day life. Okay, this is the supercomputer, because they don't know exact computer science. Okay, so we can't define any device like a supercomputer because the innovations cannot stop. Before 20 years the people don't know the term quantum computer or the quantum computing. So still the people are working on the post quantum. That still means they are just thinking what will happen if the quantum will come, quantum computer will come in the mass level. So post quantum means something which is going to be happen. Are you getting my point or not? So we cannot define this term, that is the supercomputer, and it does not exist until and unless, okay, the universe exists. Are you getting my point or not? So in our today's session, our ultimate goal is to understand the double slit experiment. See, we are not we are not from the background of physics, so we will not go in the detail of physics. Okay, rather we will try to apply those experimental phenomenon in our computer science field. That's all. Means how those things are happening inside the physics, what is the quantum physics, we are not bothered about it. Being a computer science students, our ultimate goal is, if this is the experiment and this is the result, then how to utilize or how to correlate those quantum physics experiment in our computer science field. That is the in our computer like quantum computing field. Are you getting my point or not? So if you want to see the double slit experiment, like if you want to visualize it, then what you can do, you can type double slit experiment on YouTube, and there are a lot of video from where you can have the like a clear visualization of these things. I'm not going inside the depth of that, rather I will utilize the property of those experiment in our computer science field to teach you quantum computing in a better way. Okay, so let's come to the double slit experiment. So my dear friends, just I'm giving a heading, that is the double slit experiment. Okay, double slit experiment. So what exactly the double slit experiment, if you are from the like computer science background, means you have already passed those phase 11 and 12th, where in physics everyone taught about this experiment. Yes or no? Yes. So in double slit experiment, what we are able to conclude, that light basically behave like a photons as well as wave. See, the earlier the scientists like Newton and Einstein experimentally proved that the light basically behave like a photons, and the people, means all the scientists, was assuming that yes, it is behave like a photons, until the another scientist came into the picture, that is the Thomas Young, who proven that no, the light do not only behave like a photons, it also behaves like a wave. And this proof was given by the double slit experiment, and from that time the people started saying the light basically behave or basically shows dual nature. The light basically shows dual nature. Okay, so how basically the light behaves like a wave, that is the part of those experiment. I will strongly suggest type this experiment on the YouTube, and you will have a lot of video about this. Okay, how it basically behaves like a wave. So till that time, when the Newton and Einstein was working in the field of physics, at that moment of time, it is always called that the light behaves like a photons only. But after this experiment, it was proven that the light behave like a wave. So please try to understand, in the field of physics, the people first of all try to prove something by some experiment, and then various mathematical explanations are given behind it. Are you getting my point or not? This is very important thing. First, they prove the things by some experiment, because the experiment is possible over there. And then they give some mathematical explanation behind the outcome of this experiment. Okay. So our objective is not to teach you about the physics over here. Okay. Just to tell you that the light sometimes shows the behavior of photons, and sometimes it shows the behavior of light. Okay, in some experiment it shows the behavior of photons, and in some experiment it shows the behavior of wave. Okay, so the most important part of this double slit experiment is, okay, see what exactly the double slit experiment, let me tell you something. Okay, so suppose there are two slit, means these are the gap. Okay, and you have just put some plate over here. Why we have put plate over here? So if the light will pass through these two slit, means there are two slit, means these are the gap actually. Okay, these are the actually gap, okay, between the slit. Okay, and that's why we are saying it two slit, and you have just put in some plate over here. So once you will pass the light through this, okay, it will behave like a wave, means the things will be scattered out due to interference. Okay, but once you will put some detector, this is very important thing, once you will put some detector over here, what will happen? It will start behaving like a photons. And that's why from the double slit experiment, the people has proven both the things, that the light sometimes behaves like a photons and sometimes it behaves like a wave. So if I have removed this detector, then the light will only shows, means you are just throwing the light from here, the light only shows the behavior of wave. And once you will put some detector over here, it will behave like a photons. Means obviously, if you are sending some particle through this slit, in reality what should happen? Once you are throwing the particle through this slit, means the particle will come over here, means you will be able to observe some spot here and some spot here. Yes or no? But how it is behaving like a wave due to the interference? Okay, that is again important thing. So if I have removed this detector, it is just showing the behavior of wave, and if I have put some detector over here, it's just behaving like a photons. Means only two, means at two different places we are able to observe something, nowhere else. Are you getting my point or not? Again, it seems to be illusion. Yes or no? Let me give you some real life example. Just imagine there is a fan, ceiling fan in your room. So if someone is not watching it, means someone is not detecting it, it is rotating. And once you will try to see it, it is in a static phase. It seems to be unbelievable. Yes or no? Like this. It seems to be unbelievable. If nobody is watching it, it is rotating, and once I will start observing it, it is in a static position. Just take another example. Okay, I hope you people are familiar with the term illusion optical image. You can type this on the Google, you will have a lot of images like this. Okay, how the illusion optical image work? So if someone is not watching it, it is in a static phase. Obviously it is the image, it cannot rotate. Okay, if someone is not watching it, it is in a static phase. But once you will start watching it, once you will start observing it, it will again moves into a rotating phase, and that's why the name was given as illusion optical. Are you getting my point or not? These are the something in the field of science which the people cannot believe, but this is the truth. But this is the truth. So here like we are not going inside the depth of physics, that is the quantum physics. Rather, we will try to utilize the properties, the phenomenon property of photons. So one day, one scientist, what he has done means, obviously we are, means if you are throwing the light, means if you are passing the light through here, means what? If light contains the infinite number of photons, or you can say it contains like a million of photons. So what exactly we are doing? We are passing the million of photon through double slit, and we are able to observe the two different behavior, dual nature of light. One day, one scientist, what he has done, he has thrown only single photons, and that innovate the quantum computing. So what he has done, he has thrown only single photons through this double slit, and still at that moment the single photons shows the property of wave. So means if you will think about it, you can just imagine this, how these things is happening. But this is the truth. Means if you are passing only one particle, what you can imagine, if the particle will go through this slit or it can go through this slit, and only one spot should be created over here, yes or no? But how the single particles, or you can say single photons, is showing the nature of wave, because the wave can be created only due to the interference, So to interfere, there should be something else. Are you getting my point or not? How the single photons can behave like a wave. So this emerges the concept of quantum computing. So my dear friends, as I told you, I am going to utilize the phenomenal property of this experiment to learn the quantum computing. So what is that? So due to this dual behavior of the single photons, we define a state. That is called the superposition state. So what here we are able to observe, like just imagine, means the scientist has passed only single photons through the double slit, and he can also observe the dual nature of photons, and that is called the superposition. So a new term came into the picture. Means just imagine this like imagine this in this way. Okay, so the single photons is basically behaving the nature of two different things. Sometimes it is behaving like a photons, and sometimes it is behaving like a wave. So just imagine like this. Means it should not be correct to use this term here, but just imagine like this. If this things is happening, means a single photons are staying in two different state. Just imagine like this, two different state. So if I have given this name as a state, if I have defined these things as a state, so sometimes the photons is staying in the state of photons, a single photons, and sometimes it is in a state of wave. So just define this state like 0 and 1. That is the 0 and 1. Means a single photon can behave like a 0 or can behave like a 1. But at a time, once you will try to capture this value, you can see only one thing. Either you can see the things like a photons, or you can see the things like a wave. You cannot see both the things simultaneously, but both the things are existing simultaneously. Are you getting my point or not? See, please try to understand, because this is very important for the quantum computing aspect. Please try to understand. See, the single photons is behaving like a photons as well as wave. That depends upon these things. That is the detector. Means if you will try to watch it, it will behave like a photons. If nobody is watching, it is just behaving like a wave. So just give the name of these two things as a state, where I have just assigned the name 0 and 1. Means obviously from the single bit, if you will try to imagine this like a bit, a single bit can contain two different values, 0 or 1. So just try to imagine if both these values are existing simultaneously. But at a time, once you will try to observe it, you can observe only one value. That is the very important concept due to which the quantum computing comes into the picture. And those kind of state has given a name superposition state. Superposition state. Are you able to understand? I hope these things has given you a lot of clarity what exactly the superposition state is. In the last session, I have already differentiated the classical computer to the quantum computer. In a classical computer, at a time, the single bit can hold only one value, either 0 or 1. But in quantum computer, a single bit where we have assigned the name of the bit as a qubit, that is the quantum bit. A quantum bit can contain 0 and 1 both simultaneously. And this is the experiment which shows the nature of these things. Are you able to understand? I hope some clarity has come into your mind. Yes or no? So these things is basically called as a superposition state. And how you can define the superposition state means obviously we will go inside the mathematics later on. Once I will start the things from the next lecture, I will go inside the mathematics. Just don't worry. So in quantum, basically we define the superposition state as a ket of psi is equal to alpha ket of 0 plus beta ket of 1. The condition is mod of alpha square plus mod of beta square should be 1. I will give every explanation of this. So just don't worry. Right now, whatever I am just telling you, just try to understand. See, in classical computer, we define the term bits. Okay, but in quantum computer, we define the same term as a qubit. That is the quantum bit. Okay, and this is the notation which we basically says. This notation we says cat. So once I will go inside the mathematics and inside the details of quantum computing, okay, there are various new terms has been defined, out of which this term is basically called as a ket. So how we can read these things? Ket of, this symbol basically represents psi. Ket of psi is equal to alpha ket of 0 plus beta ket of 1. Means this is nothing but the qubit. This is nothing but a qubit. Means a single qubit can be represented in a linear combination of alpha and beta, where we are trying to show that a single qubit can be in a state of 0 or 1 simultaneously with some probability alpha square for 0 and beta square for 1. So obviously you might be thinking, sir, how this is showing the probability and all those things. Those are the part of discussion that I will discuss later on. Just don't worry. To reach here, we have to go through 3 to 4 different video lecture. Are you getting my point or not? To reach this point, okay, in the regular class, you have to go through my 3 to 4 video lecture. So obviously we will try to design a model. Okay, model of computing. So first of all, we will start from the deterministic model of computing. Then we will see the probabilistic model of computing, and then finally we will go to the quantum model of computing. So how these transitions are happening from the deterministic model, how we are coming out to be a quantum model of computing. Those are the part of discussion. That I will start discussing from my next lecture. So my dear friends, I hope those who are very interested in the field of quantum computing, they have definitely enjoyed these things, and definitely you got some interest in the field of quantum computing. So just don't worry, I will explain each and every small term in a broad way. So be with me. If you are liking this video, please put some comment, because already I have told you this video is made only for those students who are trying to do research in the field of quantum computing as well as in the post quantum field. So I hope if you are liking this, you can hit the like button, you can put your comments, as well as you can share this video with your friends. See, I am already a PhD scholar. I don't get time for in my everyday life, so it is not possible for me to post the video day by day. But definitely, I have made some target, and in 3 months, I have targeted in next 3 months or till June, I will post all the video lectures related with the quantum computing, and you are going to enjoy it. And later on, I will give you some like application of this, where we can apply the quantum computing to solve the problems. And I will try to cover some mathematical part which is basically needed to understand each and every concept of the quantum computing, like basic of probability, matrices, okay, and vector space. These are some mathematics which I will use very in a huge inside this subject. So please try to go through this mathematics things, and later on, once I will start applying it, definitely I will teach you separately. Just don't worry. You just give your effort to learn this. Later on, I will tell you how these things are basically uh, we are applying inside this subject. Okay. So thank you very much. See you all in the next session.